Hi everyone, welcome back to my channel. So this is Josephine, and today I thought that I would go over some more problem sets. So this is like basically some of problem sets from like exams and things like that. So this will be organic chemistry. All right, let's dive right in. So this is basically asking you to predict the major products or products. So there might be one or two. So it's basically up to you to determine which type of products you're going to get. So starting with A, I see that there's PCC. This is basically oxidation. And then the fact that this is telling you that this is in excess means that you might oxidize something more. So PCC basically oxidize alcohols, in this case, to ketones or aldehydes. So this would be this. So looking at this right here, I can tell that there's this alcohol and then this alcohol. So the product that I should be expecting to form will be something like this and then something like this. All right, let's move on to B. Looking at B, we have sodium hydride. We also have this alkyl halide. So the way this mechanism goes is that you're going to have sodium hydride will just depronate this hydrogen. And then you now basically have your nucleophile. This will now react with your electrophile via an SN2 pathway. So the product that you're going to form will be this. So that's B. And then let's move on to C. So for C, you have this alkene reacting with sulfuric acid and water. So whenever you have these type of reactions, it's basically going to be some kind of like addition reaction. So the first step is that you're going to most likely protonate this alkene, excuse me. And then this will give you the carbocation. And then this will just follow up with water addition. And then last bit, we're just going to depronate this proton. You can use water or the conjugate base of the sulfuric acid. It really doesn't matter. So that is C. Let's go ahead and do D. I see some of the key showing up here, so I'll go ahead and remove that. All right, so for D, we have this alkene, and it basically goes into an alcohol. So whenever you see this type of problem, you quickly think of addition of water or some type of alcohol to an alkene. And one reaction that always comes to mind is the Mercration reaction. So whenever you take this, react with mercury in water, then this follow up by reduction, that should give you these two products. Let's move on to E. So whenever you see E, you definitely have an alkene. You have a hydrogen here. So for this type of problem, this is a strong base. So this is definitely probably going to be an E2 reaction. So from this on, you will get this type of intermediate right here. So that will be the product. Let's move on to F. So whenever you see F, you have these two bromines and you're going to replace that. And as a result, you're going to have form an alkene. So this is going to be some type of elimination reaction. So for this, I will do sodium hydride and in sodium and I will use XX for this. So once you do that from step 1, you should form this type of intermediate like this. And then as you can see, we have a cis alkene. So the only catalyst that goes from alkyne to a cis alkene is using the Linder catalyst. And then you're going to need hydrogen. So that's F. Let's move on to G. So whenever you look at G, you take this alkyl halide. This is forming the magnesium Grignard reagent. This is going to form MgBr. So this is from step number 1. Excuse me. This is from step number 1. Next, we're going to take this and react it with an epoxide. So you know Grignards are nucleophilic. So in this case, this is going to add here. You open up this epoxide. We get something like this. And then last bit, we're just going to do an acidic workup with a source of proton. So all of this is step number 2. This will give us this intermediate right here. And then for 4, we're going to do a Pcc oxidation. So that should turn this alcohol to an aldehyde. And that's the product for G. And then let's move on to H, which would be the last problem. So from H, it seems like we have an alkyne, excuse me. And then it seems like these products are anti to each other. So it seems like we might need to go through a trans alkene. So from step number 1, we should have a trans alkene. And I'll put a phenyl group. And then from 2, we see that we also form an epoxide. So I'm just going to do an McPba. And that should take this to the epoxide, which is our product that we see. So that's pretty much it that I have for you guys. Once again, thank you so much for joining me. Don't forget to like, share, subscribe to this channel. And I'll see you guys in my next video. Bye, y'all.